Hello. Um, this is a incredibly professional um, tutorial for my code. This was a project that I did for my computer science class, my junior year of high school. Um, I plan on publishing this to GitHub if I haven't already. I have. Small. Oh my God, this is hilarious. Yeah, save that. Yeah. Okay. Okay. Um, let's pull up GitHub hit right here. Okay. So this is the GitHub page. I haven't touched a repo yet. But wait, what the heck? Excuse me. Whatever. Anyways, this is me kind of walking through my code, how it works, because if you're like me and are a little confused at whatever random Joe Schmo who wrote Joe Schmo's code for Joe Schmo's library that you absolutely need because it's vital and very important to your project, but the documentation is non-existent and you have to sort through encrypted Egyptian hieroglyphics and fighting egotistical Discord moderators to get any information on it. Cough, cough. Java development support Discord. Um, if you don't feel like doing that, this is for you because sometimes trying to find out what they wanted you to figure out is not the nicest way to figure things out. So I made this, um, video, kind of explaining the code and how things work and how you can use this potentially if you want to expand on it. Um, we have assets here for like this pen vector thing. I never ended up, at least so far, I haven't implemented images like displaying for tools, but I will. We'll get to that. This is a kind of beta thing for a N64 emulator. Um, didn't write this. This was just me putting it in for documentation so I can reference it. This was Google Gemini giving me some tips on bit shifting. Uh, yep. Big Indian. Yeah. Okay. Cool. So we're gonna start up here. We need Pygame. That's what's handling my graphics because PyQt is for the devil and tkinter. I would rather. Uh, I would rather probably. I think I would probably. I think I would probably eat like. I think I'd probably eat my dog over like a slow roasted fire before I script anything in tkinter. So we're using Pygame because I have experience with Pygames, so it works. We have pillow. Um, it works. It's great. Well, with images, it's imaging. 1999, I guess. It's great. I love it. If you want to install pill, you can go over here, Control plus. Really? No. Whoa, that's cool. So you type in, it won't let me, but because I'm doing this, I would have to do Python. I'm in a virtual machine right now. So you would do like Python 3 uh, VNV.VNV, and then it will generate it, and then you do Ugh. God. Ugh. Oof. Okay. There we go. Source, you know, root.venv/bit/activate. Okay, so it's just source. I couldn't remember if you needed to do like Python 3 TACM or whatever. I wasn't sure, but you don't. So we have some initialization stuff here, clock, pygam.clock, not really required, I suppose. We're defining screen, this is all, I'm not going to go into, this is not a Pygame tutorial, this is not a tutorial on how to create and use Pygame, this is me explaining my code, so I'm not going to teach you how to initialize a Pygame project, I'm just going to assume you already kind of know that, and if you don't, pygame.org, docs, scroll, done. Look at how fast that was. There you go. Got some colors, color stuff. We got a font, line height, we have some initialization. Okay, now this is where we get things interesting. User class. This is not really for the user, I suppose it is. It is more so, how do I say this? It is the project. This is the god. This is the soul of the program. Everything referenced in user is referencing basically the universe. This is a program given to me by God. This is the greatest sprite maker you will have ever seen. For now, Krita, it's a little better. I think it's on par, like at least on par. Krita's good, it has some things going for it. It's real. It's overrated. It's overrated. This is great. So we initialize, for each user reference, you really should never ever have to. I don't actually know what would happen if you tried to have multiple. It wouldn't be a good idea. It wouldn't really do anything. It wouldn't break much. It would just require more work. It wouldn't do anything though. Um, so for each instance, you have a tool. One is pen, two is eraser, and three is buckets. You have three tools currently. You have an active color. Black is the default. We have multiple texture formats. I put in 5-bit later. That's fine. It's 4-bit. So you can see here, this is based for the N64. I plan on putting more work into making it more functional for the N64. Um, a single 8-bit texture format can hold a single palette, but you can have 256 possible colors. 4-bit though, you can have 16 palettes, but you can only have 16 colors per palette. So yeah, it's up to you. I just chose to use 8-bit as the default. It's convenient. Um, I don't have to do any bit shifting or whatever. So we have a function here called change tool. Um, I was a little silly with it. Um, if we're gonna pass in the string or an integer. Next tool is what we're changing the tool to, right? And if it's a string, we do a match case, and if it's a pen, we set it to 1, blah, 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 blah. Else, if it's an integer, yeah, we'll just set it to next tool. This is a, um, what's it called, interface class. If you know C or have used C at all, you'll be familiar with this. I fought my dad thoroughly over creating this class in the first place because I said it was dumb and stupid, and creating a class to do nothing is dumb and stupid and pointless. Um, it's not. I was wrong. That was naive. It's very helpful. It's very helpful. Mostly for linters and for readability. It's mostly really helpful so my linter knows to yell at me, and it's helpful for like hierarchies, derivatives. This is basically just saying that anything that we're going to derive from iDrawable will be drawing. We'll have a method draw. And here's our first one. Wow! Button class, and it derives from iDrawable. So this tells the reader, the scripter, wow, I'm in this fun thing. I'm so excited to work. Look at all this awesome stuff. Wow, I wonder what button is. Oh, it's an iDraw. Oh, so it's gonna be drawing to the screen. It is literally anything that will ever be drawn to the screen will in some form derive from iDrawable. Okay? And our initialization for any button ever, anything that is a button, will have text displayed, and not technically, um, technically, you could just give it an empty string, and I actually do at multiple points. You just give it an empty string, you would just do like, button, and then you'd pass in, text equals like that. I do that a lot. It does things. And it makes so I don't actually display any text to it. We give it the x coordinate and the y coordinate. It's the top left. So, Linux drawing, sure. Let's use kdraw. Where is it? Oh, that's kwrite. That's fine. This is fine. So let's say like, if this is our screen, this is everything that can ever exist. Where in the screen do I want to put it? X, this is Y, and this is X. Where are the coordinates that I'm placing things? I don't know I'm explaining this. You should already know this, but if not, I like to explain things. X, it's in the top left. So let's say we're going to put it here. From there, we're going to pass in width and height. You're probably wondering, okay, well, how is it going to expand to make our rectangle? What do we do here? Width and height. It expands this way. So when you're subtracting, this is 0, 0, and this is, max or whatever. So when I subtract, it goes up, and when I subtract from the x, it goes left. Little counterintuitive to the y, but you get used to it. And it will expand like this. So the x and y coordinates are the top left, and that's important for a lot of text placements. Like you'll see self-text x equals the x position of the rectangle plus the width of the rectangle divided by 4, and then I do -7 for some just hard-coded manual adjusting. I'm basically trying to center it. And the reason for this is because rects, in Pygame, rects and text objects, um, they're all surfaces, and I'm just displaying one surface on top of another. So I have to set the top left coordinate of the text to be in the, you know, center or whatever of the object, so it's centered. It's weird. The color of the button, so the button that is there. This is gonna, hold on. There we go. Much better. Excalidraw. This was some old planning I did a long time ago. Um, in our box, what is the color of the inside? What is this color? And then we're going to set the color. Text color, text Y, self.text equals self.text. So this is saying that these are parameters. You already know how this works. I'm over explaining. I'm gotta, have some. I'm only 14 minutes into this. I gotta, truncate this a little bit. Still drawing. We draw a rectangle, which we defined up here. Draw text. We pass it the text, yeah. Click. We don't do anything. It's like an interface. Everything that's button will have click. Export button, this is our first really interesting thing. This is the button that will export the image. And I'm going to give you a little spoiler. Boom! That's an image. Um, so we're going to really take everything, but we're going to set a default text color that's black. And we're going to say if the texture format is 8-bit, we are going to get the raw colors. So we're getting all of the colors for each grid of the cell, and then we get the pixels, and we convert it to a NumPy array, and giving it a NumPy unsigned 8-bit integer. Unsigned integers, which means it's really just absolutely, it'll free up an extra bit when you're defining it. If you know about binary and how data is represented in bytes, you'll realize that for negative numbers, signifying that it's a negative takes up a whole bit. So by doing an unsigned, you can essentially double the amount of possible numbers that you could hold. So by doing it unsigned, it just really is a lot smarter. Oh my God. I just, I felt like this dude just now. I felt like this guy just right now. It really is just a lot smarter to use an unsigned integer because it frees up a whole bit for you. Doubles the amount of possible colors. Anyways. This is essentially just because it's like a try except, you know. This is my dummy way of try, except. We're just going to say if, again, this is a dumb way to do it, but it is fine. We're saying if it equals this, I should probably explain this. Okay. Okay. So we're saying that for pixels, we have a NumPy array. We're saying if our NumPy array if the format of my NumPy array equals canvas height divided by cell size, which is the number of pixels on my X. Boom, 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 boom. We'll get more into when I create the grid and what the grid looks like later. Multiply by the canvas width divided by the cell size, and then times 3. Now this times 3 signifies that it's a 3-dimensional array, RGB. Red, green, blue. 3-dimensional array, 3 different channels for color. And we're saying if it is, awesome. It's in the correct format. We're going to reshape it into this format. Now you might be saying, Eric, this is stupid. This is stupid. We're saying if it equals this, set it to this. And to that, um, shut up. I don't know actually. I don't know. All I know is that I did it and it works. I could care less how optimized or repetitive it is. I clicked it and it exported. That's all I care about. I'm not trying to write the most heavily super optimized, laser efficient, every single bit must be perfectly optimized, and I have to write 60% of it in Rust, and 2% of it in Ruby, and 1.395% of it in C Sharp. Okay, it's fine. It's you know, it's the school sprite maker that I plan on working on afterwards, where it's fine. It's a sprite maker. Get over it. If else, we just kind of yell at you and just kind of say, no. We're set an image, and it's image, and we're making, this is pill, up here. I can imagine that's a little hard, but this is pillow. We're just making a pillow object, taking a NumPy array, and then we're saving it. I never checked to see if it already exists, so we'll, currently it'll always overwrite it. I should probably fix that, but eventually. Change to not overwrite or ask user. There we go. Yeah, hashtag to do. Nice. Oh, did I not add, there we go. There we go. It's actually really annoying. I went through all the work of installing. I was like, oh, that's annoying. Get that in my face. Um, else, and I add this little comment here to let you know, like, hey, we're saying if it's not 8-bit, it has to be 4-bit. And then we're gonna bit shift it by, if it's, yeah, I guess we should just bit shift by 4. I actually haven't tested this mode yet. I haven't tested this. I've only tested in 8-bit. So we save it, and now that works. Awesome. Pen button, initialize, draw it to the screen. We're all just setting up drawing stuff. You already know how drawing works. It already works. This doesn't have draw because it just derives straight from this, so we don't modify it. If you're never modifying something from the superclass, you don't actually need to identify it. We are shifting something here with custom text colors based off of variables, so I did define stuff. When you click it, we're just changing the tool, which if you remember is this, and then we just give you a little bit of terminal response letting you know that it did do something. For debugging, again, we're doing this text color, so we have to do it in it. Draw, again, we're modifying stuff, white not, so we're saying if the active color is black, which is, if you see here, the color of the rectangle is the active color, so it will actually change in real time with the color you've selected from the palette. If it is black, we're setting the text color to white, that way you can actually read the text. Otherwise, it's just whatever you want. If it is black, we will overwrite it to always be white. Clicking, we change it to the bucket. Eraser, same exact stuff, except we modify some stuff to make it all readable. We set the background to the background, we give it a border, and then we offset the Y value, make it more readable. Change it to eraser. Coolio, palette button. For each palette object, I'm gonna just run it and show you. This is it. Looks pretty ugly. Yeah, I know. This is all hand scripted. It's not gonna be pretty. So for each object here, each of these is its own palette button object. And for each one, they each have their own click method. And we just do a little verification here. And if it ever doesn't work, we just do, sorry, I tried to change the color, but it didn't work. uh, yeah. So we set the color to color. So by default, it's black. And then we can change it. See that? Look at that real time. Oh, I'll have to fix that. But yeah. Boom shakalaka. Um, and then we only make the palette once. Every frame. We're not regenerating it, we're just redrawing it. So we'll only make the palettes here once. Because that'd be stupid. Um, so we just say that for every color and colors, we set the Y value to be the position of that times 40. 40 is just like the size of it. Um, that way they're spaced apart. And then we just append palette button Y level. That way we have every single color that we defined right here. This makes it every single one of these is here in order. It's very convenient, very convenient. This is here for documentation. This is the old thing. It was really dumb. My dad helped me optimize it a little bit. We went from like 7-ish lines to like 3. Grid cell object. Each one of these is their own grid cell. Man, it'd be really convenient if I set the background color to be a color and then I could like bucket it. That'd be really convenient. Um, so each one of those grid cells has their each color, position, and their own rectangle object. We draw it, we give it a rectangle. Um, And then on clicking it, if depending on the tool, we either set one thing's color to the user's active color, either the background color for an eraser or the bucket, we just set for every cell, set it to the active color. This is, I probably auto-tabbed this. I'm gonna leave it because I'm worried about I'm worried that it's a TF2 coconut. Or I suppose the TF2 two-fort cow cardboard stand. Um, if you know, you know, I guess. The coconut's a fraud. So again, we only make the grid ones because it'd be stupid if we did. We just do for every range, for every row in the canvas height divided by cell size. That way we can eliminate how many things we want. And then we do every column. This divides into a neat even grid. We do some math here. I would love to explain this, but I made it a long time ago and it's 11:45 right now. Essentially, I'll do it really quickly. X equals the column, so remember, we're incrementing by like 0, 60, 120 or whatever, times the cell size, so it's like 1 times 60, so now it's 60, plus screen width divided minus canvas width divided by 2. This is all centering, it's all centering. The reason I do this is so that I can center it, because before, at the start, the grid would be in everything. The way I was able to get it so that it would be centered and offset here is this. This is how I did offsetting. We mod by canvas width and canvas height so that we can just double make sure that it doesn't go where I don't want it to go. And then for each item in grid cells, we just print the item. It's, you know, needed to be done. I don't know. I do it. And then we just return the grid cells. Make buttons. Again, we only make the buttons that you see, export, pen, eraser, and bucket. Only do it once. Only do it once. Draw them every frame. Initialize them once. We pass in parameters. You already saw this. I'm not going to go over it again. This is where we actually make them, though. We don't. Okay, now here we draw text. I'm sure you saw earlier functions like draw text. This is it. You take in the text that you want, the positions, the color. We're just going to be a tuple. It's a 3 tuple. I didn't know how to tell it was a 3 tuple. So lines equals, we're going to split by, \n. We don't actually ever use this, but it is good to know. It's really convenient so that we can do multi-line things for text. We never use it here, but I have in other projects. We just do font.render, the main text, and then we blit the screen. We've made the text rectangle. This is where we make our surface. We get the rectangle of the font render object. We define some positional stuff, and then we blit it onto the screen. This is actually what draws it to the screen. This line here, 246, actually draws it. Define these three, 249 to 266. This is basically the same function, just with a different parameter. This is just saying, we'll show you what calls later, but the rect one is always the mouse. You can see I named it mouse rect. So the cursor, if I click something, we're essentially just saying that if it collides with any rectangle in this list, we're going to return the index of buttons indexed, clicked button index. So we're saying clicked button index equals this walrus operator here is great. What it does is it's a clicked button index equals rect1, which is mouse.collides list buttons rect. So it's saying if it's true, so if this is true, we're going to assign it the result of it. And then we can do buttons clicked button index, which would return us which button we clicked. It's great. It's amazing. We do the same thing with the palette, just instead of button, we return a list of palette buttons, and we pass in palette list and do palettes. This is the exact same thing with grid cells, list of grid cells. Same logic. Walrus operator saves everything. We initialize the user class into a user object. This is our main. Everything above running will only run once every time main is called. We set running to true, we make the grid, we make the buttons, we make the palettes, and then we append, we extend drawable objects, which is a list of drawable of iDrawables. We extend grid cells, buttons, and palettes, which if you saw here, we append everything to. Earlier when we make things, we're appending it all. So this is really just making sure everything gets drawn, which we do right here. For this is some list comprehension. No, it's not. It's not list comprehension. We know that .draw is a method each drawable object will have, so we just do for every object in drawable objects, we just draw it. While running, for each event in pygame.event.get, so for each event that happens, if it is quit, running equals false. If it is a mouse button down, we get the position of the mouse. We get we define a hitbox, so I define a rectangle, a mouse click hitbox. We print the position of it. If it collides with anything in buttons, cool. If not, we check if it collides with the drawing grid. If not, we check if it collides with the palette. And it can't be, and if it's none of those things, well, we don't do anything because you click nothing. Every frame before drawing our things, we set the everything to background color. And then we do flips, which actually updates the screen, and then we collect that tick at FPS. Woo! Look at that. 30 minutes and I explained 300 lines of code. What is that, 10 lines of code per minute? That's pretty solid, especially considering 90% of this is white spaces and comments. But that's it. Any questions that you have regarding my code, or if you want to contact me in really any way, you can feel free to do that at my GitHub. You can go over here. I was not happy working on this. I was really unhappy working on this. I was quite unhappy. You can go to my profile here, github.com/bluedogman, capital B. Um, I'm a professional. I'm a professional in Python. I'm fully proficient in Python, soon to be certified, but who could care less about Python certification? Not me. And I don't think any job employer is really gonna, you know, be excited when they get in there. Whoa, guys, this guy's got a Python certification. Now look at this. Look at Mr. Big Guns over here. But whatever, it's one more thing to put on a application or something. I don't know. I get a little shiny medal. I like Kotlin a lot. It's better than Java. Android development's it's a thing. I have a couple projects on here. If you ever want to contact me, feel free to go over here to my GitHub. And then I don't really know. I'm sure there's a way to contact me on here. Or I don't know. Maybe, I don't know, go to a project and leave a issue or something. Or you can go to this here. This is a Google Sites page. I know I should be using Google Cloud or GitHub Spaces or whatever. I don't know. I don't. I host some stuff on here, and then you can like click here and then go to like, oh, I can't show you, but it'll show like contact, and then you can contact me. You can like email me. My email is, oh, I should, okay. I'm not gonna show my email. I'm gonna upload this. I have to remember that. I don't want to accidentally show something I shouldn't. Okay. This is my email. Feel free to contact me here. Um, you can send me an email, and I'll probably see it. Um, but yeah, uh, hope you enjoyed. Um, I think that's about it. Yeah, okay, cool. Outro. Um,